All right, so we can use the same process when we have just an equation. It doesn't have to be set up the way it was in the last problems, the y equals. So for example, in number 3 we have this equation, negative 3x plus 20 equals 5. Now I know that that's a pretty simple one to solve. We can subtract 20 and divide by negative 3. But I want to show you another way you can use to do this problem, and it's going to be helpful on the later ones that are more difficult. So what we're going to do is we're going to split this up into two functions, each side of the equal sign. One of them is y equals negative 3x plus 20, and the other one is y equals 5. So I've just split it into two pieces. What we're going to do is we're going to graph both of those and see where they intersect, and that's going to give us our solution. Now, some of these get a little bit more complicated, so we are going to head over to Desmos to actually do the graphing. That's not what I want. So in Desmos, we'll type negative 3x, y equals negative 3x plus 20. And we'll also type y equals 5. Okay? And it's graphed the two lines that I want to look at, and it's given me the point of intersection, which is 5, 5. Now, this was an equation that was only in x, so we only need the x coordinate of this answer. Our answer is going to be x equals 5. So when we come back over here, all right, x equals 5. Now, you might be asking, like, well, why on earth would I do that? That looks like a lot more work. I could have just subtracted 20 and divided by negative 3. Yes, absolutely, you could have. But you can see number 4, that gets a little bit more complicated, and definitely 6 and 7. So we're going to do these using Desmos. So what I want you to do is to split this. Okay, these are your two different functions. One of them is going to be y equals the absolute value of x minus 4. That minus sign just did not want to show up. Here it is. And the other one is going to be y equals 1/2 x plus 1. So we're just going to graph each side of that equation separately. So let's head over to Desmos. Get rid of these. So we have y equals the absolute value of x minus 4. And y equals 1/2 x, nope, not like that, plus 1. Okay. And we're going to look and see where these solutions are. Now you'll notice it intersects twice, here at 2, 2 and at 10, 6. Again, we only need the x coordinates, so our solutions are going to be x equals 2 and x equals 10. So when we head back over to our notes, we'll say x equals 2 and x equals 10 are our two solutions. Okay. And what happens, just so you can see this if you check, I'm just going to plug in 10 because that looks like fun. So if I plug in to check this, I would say, is the absolute value, I'm going to plug in 10 right here, of 10 minus 4 equal to 1/2 times 10 plus 1. And I think you find you do that, they're both 6, and so it does work out. If you plug in 2, you're going to get the same thing. All right, let's check out the next one. I'm not going to write out all the pieces, but I'm going to put both halves of this. Y equals that left half, y equals the right half. I'm going to put that into Desmos. So we'll get rid of these. We're done with those. Y equals x squared minus 4x plus 1, and y equals x minus 2. So here we have that graphed, and these are not very nice and neat numbers, but that's okay because we can still solve this. So it looks like 0.697, 4.303. I forgot them already. 0.697 and x equals 4.303. All right, let's check out that last one. Again, we're going to graph both sides of that in Desmos. So head over to Desmos to do that. First one is y equals negative x squared plus 8x minus 13. Hopefully I typed that in right. And y equals x minus 4. I just need to double check that. So what I had right here, plus 8x, yep. Okay. Sorry, just checking my work. Again, not very nice, neat numbers, but we do have answers, 1.697 and 5.303. Okay, so if we don't have linear equations, sometimes it's harder to do them by hand. We wouldn't really want to graph this one by hand, but we can still solve these things using the same methods that we use for those linear equations.